In early 2014, Adam and I met with Evernote, which produces productivity software. Now, I had known about the software beforehand, but Adam had actually been using it for a number of his projects for some time.
I'm often looking for ways to better manage my side projects. I work on things that might take years, where I might work on it for a few weeks and then let it go for several months and need to know where I was. And as I asked around, Evernote kept getting recommended to me as the perfect solution.
So we formed a partnership, and as a part of that partnership, Evernote offered to support us in building anything that we wanted. I decided to run an experiment on a new type of power transmission and apply that towards a project I call Racing Spiders.
The complication here was an accelerated build schedule. Evernote wanted the Spiders completed in time for their annual conference, but for several weeks leading up to that, Jamie and I were going to be all the way across the world in Australia.
And that's where Evernote comes in. This is the story about how Jamie's Racing Spiders were brought to life.
So, how do you manage a project as complicated as Racing Spiders when you're not even going to be in the building?
Well, obviously, I'm going to have to delegate the work if I can't be there personally to manage the project. And with something as challenging mechanically as this, there aren't a whole lot of people that could do that. So I decided to engage the services of what used to be the Industrial Light and Magic Model Shop. Now they've formed a company called KernerWorks. And I figured that if anybody could pull this off, they'd be able to.
Tell me the team that you were working with at KernerWorks.
The lead was Michael Lynch. As far as abilities, Michael is the closest to me as anybody that I know. One was Mark Wayless, who actually used to be my boss during Arachnophobia. That was my first major movie, and I designed and built a lot of small mechanical spiders there. The other two guys, one is Scott McNamara, who's a really good machinist. And then there's John Foreman, who is very strong in the electronics. So I met with them at their facility in San Rafael to introduce the project and the engineering trick that I wanted to apply to my experiment.
Felipe's here.
Hey, hi Jamie.
Hi guys.
How you doing?
This principle of substituting compressive and tensile loads for bending loads can increase the strength of a structure greatly without adding much mass. My thought was that by applying this to power transmission and using super strong lightweight materials, we could make structures move at speeds that would otherwise be impossible.
So your plan is to use super lightweight materials and to make a normally static load dynamic, but why apply this engineering principle to spiders?
Generally, spiders have very long, very thin legs, and that means that there's going to be a lot of leverage at the base of those legs that can, make them fail. So this technique of using high-strength lines for power transmission potentially can be a way of making those legs dramatically stronger without adding any particular weight to them. But the project I took to KernerWorks is actually just the first step in a larger, grander plan that I have of scaling these things up to such a degree that you could actually ride on them.
Riding racing spiders.
Yes, very fast, very large spiders. The large mechanical spiders I've seen have always been massive hydraulic devices that are too heavy to move fast. My design avoided this by using lightweight, high-strength lines in place of mechanical linkages, and it used carbon fiber tubes for legs. These legs would operate like oars, similar to another spider I'd built for a TV commercial.
Okay, so let me get this straight. In order for these spiders to be steerable, they're operated in two separate independent halves with 16 lines per half operated by a crankshaft?
Yes, each side has its own motor and its own crankshaft, and that's the way that I had drawn it out on the initial large-scale CAD drawing. But there's another way of doing it which I believe is better, and that's a wobble plate. The motor on each side will make this plate oscillate, pulling each of those 16 lines. Wobble plates are normally used in things like pumps, not so much for operating spider legs, and it made it truly an experiment.
So how long have you been thinking about this?
I've had this kicking around in the back of my brain for a while, and you don't really need to have racing spiders, but it's sort of the ultimate mechanical linkage challenge, which I'm really fond of, and I wanted to figure out a way of putting that principle to the ultimate test.
So lightweight, streamlined,
speed.
Yeah.
Those are the priorities for the design approach for the whole thing.
Yes.
Okay. Simple. Huh.
Yeah.
That's easy.
But
Okay.
nothing
check,
to
check,
figure
check.
out here.
So, was it simple?
Well, actually, maybe not quite as simple as I thought.